Well, good evening. Ah, Matt got his ears on.
That's it. 10-4, good buddy.
Apparently, I was just sitting here talking to myself.
Oh, okay. Yeah, I was just getting up a page here. Let's see. Let me turn on sharing for everybody in case somebody wants to do a show and tell or show us where they're having trouble. You doing okay? You got everything caught up good and everything?
I was going to send you a schematic. You remember? Let's see. I think we probably did this back in 2015, 2016. You and I were looking at that field day audio.
Yep, I remember it. I
I
still have it.
We came to the conclusion that the expense was far outweighed.
The benefit?
Well, somewhere along the line, I started playing with it and I cut it down to, instead of there being 12 ports, switches, pots,
Yeah,
all that, instead of it being 12, I got it down to where there were 9 and eliminated some of the other extraneous stuff. And so I happened to cross it trying to do something else. I saw it, I brought it up. And then one of the things from what we had done was, oh, well, it needs to be on a page. And so I went and I said, okay, well, create the page. Well, the drawing is like about half in the box and half out. I can't figure out how you get the schematic into the box.
when you're printing?
No, this is just on the screen.
Oh, you just select everything and drag it.
I tried that. Now, maybe I was dragging the wrong thing, but because I couldn't change their outline. I couldn't change that. Let me bring it up.
Yeah, you can just put a rubber band box around everything and drag the whole smash around the screen. Hi, Beth.
Hi.
Well, how is it going? Any questions I can answer for you?
Well, I'm still a little confused on the schematic. I went back to your very first email with the drawing in it, and I saw that had 12 volts
Okay.
of power. But then where does that power come from? I mean, how do you get it to work where?
You have to have a battery or a power supply to supply power to this circuit.
Okay.
And in my case, it was one of these little kid cars, right? And it had a 12-volt battery in it. And the output signal went to enable the motor, the drive motor on the car. And so you saw the video of the scope trace where the pulse varied width. Well, as that width varied, the car would go faster or slower, depending on how much on time there was and how much off time there was.
Okay.
So this is called pulse width modulation. And it was just, I just picked it because it was such a simple circuit. You got half a dozen parts to work with here and not overwhelm everybody right from the get-go, We'll start small and we could build to something larger if we want to.
When I run the verification,
Yep.
I still keep coming up with those 2 errors, the power error and the out error.
And what do they say?
It's single pin in net.
Okay.
And that's what it says for both of them.
Do you want to share your screen? There we go. I see something. There we go. There's your schematic. Okay.
So I keep getting the error here and here.
I did too.
Well,
Do I need to make it bigger?
yeah, that would help. Just, go ahead and fill the screen with it. So I put a component on the board, a pin. It's called CON_mail.
Okay.
It's just a contact pin, and it gives me a reference, gives me a point to take wires off the board when we create the schematic.
I don't think I understand how to do that.
Okay. If you look on the left side of your screen there, it says filter on.
Uh-huh.
Click that.
Okay.
And under name there, hit cancel filter because you look for something else there.
Okay.
And then put CON_mail.
Oops.
And it's searching. Okay. Take and you got your choice there. You can click down through that list there underneath filter on, yeah. And you can look to see what they look like and pick one that you like. That one's 10 at a time. That's the one that I used right there. Why don't you put about 3 of those on the board? There you go. All right. And then just hit cancel filter. You can hit escape and get back to normal. And you can rotate those if you want them pointing the other direction. Okay. And then on the left-hand square box there, let's see. Go up to your 12 volts there.
Okay.
And let's see, what net is that? Mouse over it. Just put your mouse over it. And it'll tell you what net it is. So
Net 1.
go down to the wire itself. What's the wire say?
0.
Net 0. Okay.
Net 0.
So you haven't really renamed your nets yet. But anyway, take that first pin and you can, your J1.
Okay.
And
these are pins. Okay.
Yeah, those are pins. Go to the left there and right click that. And let's add that to net.
Okay, that's what I missed.
And net 0 is your power. That's your 12 volts, right?
Uh-huh.
Go ahead. Say connect without a wire.
Oh.
But they're connected with a wire. But you can delete the wire if you want to and go connect it without a wire if you want. Just right click and delete. Yeah, there you go. You're doing great.
Add to net.
Yep. And check that box right there.
Okay. Okay.
Now it says net 0 and right click on the wire that says 12 volts there. No, down to the wire itself. Yeah, that's actually the net.
Mm-hmm.
Right click on that. See if there's a rename on there for the net name. Display direction. Go up to net 0 and click on that. Change that to, you can call it plus 12V or VCC or whatever you want to call it. Okay.
Okay.
And that's renaming. Just use the plus symbol like it's the nomenclature.
I gotcha.
Plus 12V. Just run it all together.
Okay.
All right. And yeah, now you see where J1 is connected to.
Right there.
Also look to the right on J1.
Okay.
See where we connected it and set it net 0 before. Now it says plus 12V.
Okay.
Now, one thing I did to my drawing here, go delete that net port 12 plus 12V right there. Yeah, delete that wire. And go up and delete that plus 12V. Yeah, get rid of that too. And this'll just make the drawing a little more simpler. Now right click on to the right of VCC there.
Okay.
Go to the right. Yeah, right click there and add that to net plus 12. Right there.
Okay. Without a wire.
Yeah, it found it. It'll hook those two together. So those two are connected together in your schematic.
Okay.
And let's make
so then I would do the same thing to
for out and do one for ground as well.
Okay. I didn't come up with an error for ground.
Just delete the one for out.
Okay.
Because you have more wires connected to that. Just delete the wire and everything. There you go.
Okay,
Now
so
right click on out. Go to the right there. And then add to net. Okay, now at this point, yeah, you can pull down that box, see what nets you have, but there is no out net, right? Let's create one. Hit the plus symbol. We'll create one called out. Just name that OUT. There you go. And okay. And now you have a net called out. Now go connect one of those pins up there to out. There you go.
Okay. And
then the third one, you can leave all those grounds there. Just leave all those there because they kind of, they add simplicity to the drawing. Just go connect J3 to ground. Or wait a minute. Go see what net the ground is, first of all. What net is that? A little higher. There you go.
net 6.
Net 6? Okay.
So do this to net 6.
Yeah. And go ahead and mouse over where it says net 6 there on that pin. Let's see where, yeah. See all the other grounds highlight up when you do that? That's how you that's how you know you connected that to the right place.
Okay.
So click on that. Let's rename that net to GND. Net name. There you go. Okay. So now everything is looking a whole lot better, isn't it? Do your check now.
No errors.
There you go. There's also some other checks there. Go on down, look at verification again. And there's also, that's if you want to set your rules. Did you actually do that yet?
No.
Go check the hierarchy. I don't think you'll ever see any errors there. That's for like, somebody asked that question last week, and that was for multiple page drawings. So one other thing, as long as we're looking at your drawing here, the grounds on the lower left corner, you can straighten those out. Just tidy those up a little bit. Just drag it. Yep, there you go.
No, you probably have to move him.
Yeah, you just move the symbol there. There you go. All right. Go ahead and save that. That's looking good. Your potentiometer could be lined up a little better. Yeah, I just like to make things pretty, when I'm doing a drawing.
So what would I do to make it?
You could drag the potentiometer over underneath the diode more. No, not U2, but the potentiometer itself.
This?
Just drag it to the right.
This?
Yep. Drag it to the right. That's your potentiometer. There you go. It's like a volume control.
Okay. Yeah, I was having trouble with all it would say there's not a connection because I had them too close together. So I moved them as far apart as I could.
Okay.
And
a lot of times that's easier to do at first, leave some space, and you can move that wire down and move the potentiometer up, So it's a lot easier to read now.
Yeah.
Things are clearer. You've got your wires that are running off the board. So look at, click on one of those 3 pins up there. Double click one of those to the right. Yeah, right there. Double click. And on the lower left corner, it says attached pattern. Is there anybody else on the Zoom meeting yet?
I think the 3 of us.
Oh, okay.
I'm
good.
here, Steve, N5YM. Hey,
Okay.
Steve.
I'm here. If you go to gallery, you can see everybody.
Yeah, because it looks like pin 2 of R2, VCC on U1, and pin 4 of U1 are all connected to VCC. on your original schematic that you sent us in the email.
I'll have to look at that. Pin 2 is connected to VCC. That's correct.
Okay. And pin 2 of R1, of R2, right?
Of R2, yeah, that's connected to VCC. That's pulled
Okay.
high.
And pin 4 is connected to, of U1 is connected to VCC. Is that right?
Pin 4, yeah, the reset. That's
Yeah.
the term.
Is that the same way on her schematic? I can't see now because there's a box over the top of it.
Yeah, we're right in the middle of something. I'm helping
okay.
them get through a
Okay.
connector issue here. Let's see, attach pattern. So there is no pattern there, Beth. What you want to do is go over to the right-hand side and filter for a pattern. Go down, 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 up, filter.
So,
And then the name of the pattern you want to look for is AWG. And I stumbled across this just rooting around looking at other parts and
Really?
stuff. Oh yeah, I stumbled across a lot of things.
Well, okay.
And there's the different gauge wires. So say you were going to use a 16 gauge wire, you click on that pattern there and add that to that part. You hit OK. And also before you do that, oh, hang on. Let's see, J1 don't have corresponding pins. Okay, so hit OK. And one thing you do have to do is go back and look at the pattern again. You move too quickly. Go back and look at the attached pattern. And up here by the pin, the schematic symbol of the pin, the little box, click on that. Click the little box itself. Left button, left click. And it should give you a blue wire. Move to the right as you do that.
okay.
No, to your right, your other right.
There you go.
And drop that in the middle of that pad.
Oh, okay.
And so now you're connecting that wire to which pad you have. I mean,
Okay.
this is important when you get into parts with multiple pads. So now you got a wire attached. You got a pad and you got a wire attached. And also apply to other components there. Click that one up a little bit. Right there. And apply to AWG16, the lower one. So it'll change all those at once.
Okay. It says 0 have been changed.
Okay, hit OK. Hit OK there. And click on one of the other guys there. And look at his pattern. So you need to do that for all those then.
Okay.
All right.
Okay.
I think
All
you're
right.
in good. I think you're in good shape.
I would have stumbled forever trying to find that.
Okay. So you want me to stop the share? Or,
Let me see if I can do that. I can do that just by sharing my screen.
okay.
Okay. Does anybody else have any questions before we move on? Let's see.
This is not.
So last time we finished up the schematic, right? Everybody hear me okay?
Yep, sure do.
Okay. All right. It was awful quiet there. Last time we finished up the schematic and we created a PC board. We did a create PCB. Have you done that yet, Beth?
I did, but I was
doesn't-
so messed up here, I didn't know what to do.
Yeah, it didn't create right. So you'll do that step again and then it'll actually create your PC board. I had discovered something and I don't know how the setting got changed, but if you look at my drawing, everybody see my PC board drawing on the left?
Yeah. Yes.
Somehow it didn't display any of the names of the symbols. And this is another thing I stumbled across. And under view here, you can go down to, let me find it here, component markings. And in the past, I was having to go through and set every one of those doggone things. And you can go down here and say, show the value or show the reference description. We don't want the value on the PC board, but we do want the reference names. And you can set your font if you want a smaller font or a larger font for things. And hit OK. And all of a sudden, here comes all the names of all the parts. I'm like, cool. We did them all at one time. Did everybody catch that in the email? And did you have a chance to try that?
Yeah, mine was already set. It's been showing them all along.
Yeah. I don't know how mine got that way, but I do mess around with this thing so much that sometimes I turn stuff off and forget that I did it. But then you hit F10 and you can move these symbols around. Like I like to put the diode names right in the middle of the diodes and the resistor. You just grab these one at a time. I'm gonna hit spacebar and turn that one for U1. C1, I'll just stick it up here out of the way. C2 is upside down, so let's turn that. And R1. And I moved R1 to a different spot on the PC board just for grins, just to see how the traces turned out and everything. And so you can move things around. You can try to shrink the PC board because the smaller the board is, the less it costs you to have one made, and it might fit better in your project. Like we can take, say, this resistor. Let me hit escape here. So we can take the resistor and move it closer if we want to. And the diodes. And so forth. And the pot, we can move a little closer. And as I move this up and down, you can see some real fine lines there that show that it's lined up with the other part. And that's kind of cool. That one's lined up. I think that one moved. There. Now all three of those pads are lined up with each other. The capacitor could be a little closer. We could tuck this guy in a little bit. And these. And then if I just go up here to route and say unroute all of these traces, unroute all. And there you see the blue rat lines that show, you know, where things are going to get connected. You mouse over an individual pin and say run the auto router again, and it'll reroute everything for you. There we go. And if you like it, you know, you can move on from there. You can flip parts around, like this capacitor up here. If I look at that, I can move that around and kind of put it up here even closer. And you can manually move the traces if you want, like that. Line things up there. I'm going to unroute that and reroute it now.
Yeah, you made yourself a shark there.
Yeah. And then just rerun the auto router. And it's surprising sometimes when you move one little thing, how it can really affect the auto routing. So in the past, if I was really, you know, trying to cram things in, and you move one little component and just for a test and reroute things, this capacitor could be closer. I'm going to draw a box around all these here, and I'll hold down shift and just move those straight up. Shift will keep things lined up for me. And that's pretty good, really. So did anybody try to optimize and make your board smaller?
I got mine smaller than I'm comfortable with.
Well, you can always go bigger.
You know, I got mine down to 1.25 inches wide and 1.4 inches high, and I thought that looks pretty good on the screen, and then I printed it, and I realized just how tiny it was.
That will shock you real fast. And you know, if you grab those parts and lay them on that drawing, they will most likely fit. And that's one of the steps that you do want to do. You want to lay your parts on the drawing, make sure stuff fits.
Yeah, well, I thought you said you were gonna talk about making pads bigger. I didn't realize till I printed, pads and traces bigger. I didn't realize how small they were until I printed it out.
Yeah, they get real tiny. You can right click on a pad, like on this chip here, U1. I didn't quite get in the right spot. You got to get in the right spot though you right click and you can go all the way down here to pad properties. Say for U1. And if I click on type dimension and it says current pad, let's say all similar. And then I'll click the patterns, standard pad properties. And this is set up in the pattern for that chip. And he's 0.0449. Well, I'll typically take that and maybe make that 6 right there and tab down one more and let's make that pad 6. And if we're lucky, it'll change all the same pads on that chip except for the square one. That's a different kind of pad. And if I right click on that one, and we'll change him as well to 6. Yeah, I do like to beef up the pads. And you can do that for, what looks good. These points here where we got our wires going off the board, those I would probably make bigger. So one thing we could do with this, I mean, I don't like this wire, this trace being so close to that pad where we're going to solder a wire, or that one there. You just take them and drag them down, to a place where you're comfortable with them. That one's a little close to the other one there. And we can make that a corner rounded there. But
Are these boards going to come with solder mask?
yes, they will. Oh, yeah.
That makes me feel more comfortable.
Oh, yeah. That makes things a whole lot easier. Your solder doesn't run all over the place. But for this particular layout, I don't like where that trace is. So I'm just going to drag it to the other side of the board. Make sure it doesn't. Let's see. That is the same. Get him over there out of the way. And then I'm going to put a rubber band box around all this stuff. This is what I was talking to you about, Bob.
Yeah.
I'm going to hit escape here, and grab one part, and just drag the whole thing. We can set that right there. I'm going to grab my 2 mounting holes. Let's move those over. And now I can make this board smaller. And if you look down the lower right, as I move that, it's going to tell me how big the board is. There's 1.5 inches there. Let's bring that one up. It's going to be a little bit tight for 1.5 inches there, but about 1.6. And move our mounting holes again. So you can play with this stuff and move things around and get it to where you're happy with everything. Any other questions?
Steve, I saw in U1 you did all the similar pins to make the pads bigger. Now we've got on C1 and C2, those are similar patterns. Can you do the same thing on those by just picking one of them? Will it do all of them on that, or would they have to do it component by component?
Sometimes it works and sometimes it doesn't. So you can try it, or you can select both components. Let's try here. Let me see if I'm going to select that one. I'm going to hold down Control and select the other component. And I'll right click on that pad and we'll change the pad properties. And 063, let's make those 8. Bump it up a couple. 08. And yes, it did change both. Sometimes you just got to try stuff. That one almost looks a little bit bigger. Don't be afraid to, reduce one a little bit. That square pad, to me, it looks a little bit big compared to the other one. And so we could change that, his pad properties. Oh, I got one of them 9. How'd I do that? No wonder it looks big.
It's magic.
It still looks a little big. Let's try 75. That looks better. I can follow suit with the rest of the parts too. So, all right.
Yeah, you'd want to run another check for rules check to make sure you've got all your clearances right.
Check design rules. And what's he say? We're missing something here. So if I double click on that, it'll tell me that there's not some clearance there. It puts a little red bubble. There's also, let's see, in verification in the design rules, let me pull that up real quick. Okay, I don't have them set in this particular drawing, but there is an option right here, enable real-time DRC, and that will do these checks as you're going. So if I just unroute all this, unroute all, there we go. I rerouted it, it's going to put those traces in a different place. And everything's happy again. But it routed things differently instead of running between pads, because now the pads are thicker. It went around. It found a path and went around. I tell you what, this auto router, that's a lifesaver. That has made my life so much easier. And as you can see, we can make that board quite a bit smaller yet, can't we? Hit escape here, and let's just grab one part and move it up a little bit. Great, take these two guys, get them out of the way here. Just drag this in. It just keeps getting smaller and smaller. Come on. Doesn't want to lock in there. There we go. So one thing you can do is you go up the upper left-hand corner under File, and you can actually look at the layout information. It'll give you some stats about your layout. So I got a couple square inches there. So these boards would be about $10 from OSH Park right now, just as it stands. We'll make that even smaller, but that's where we're at there. Let's see.
Where was that again? That stats?
Under File and Layout Information.
Thank you.
And like if you're doing like surface mount board and stuff where you got more vias, there's 0 vias on this one, but you got more vias and stuff, it'll tell you how many you have. And I usually try to lower that number, make the traces more of a direct route if I can. Let's see.
And the vias kind of guess your total hole count or the limits of the free software. Is that correct?
There is a limited number of holes. I haven't hit it yet on any of the projects that I've been working on. In the
300 holes.
Yeah, it's a lot. It's really a lot. It's 2 layers and 300 holes. So you can't really make a 4-layer board, but which is an advantage if you're going to work with RF stuff. Sam, wasn't that you that sent me that video?
Yeah.
Yeah, Sam's got a link for a video that talks about considerations for RF design, and the one thing the guy did was put the ground plane and the power plane on separate layers, and then manually routed all these RF traces first to keep things similar and same length and that kind of stuff. And there's some checks in this software. You'll bump into it, and you can check the length of traces. So when you get into real critical timing issues with some of these really fast circuits, there's something that you might want to consider. I used to work on computers that we tuned by shortening or lengthening wires. And it was like so many inches per nanosecond. So, but not something we have to be concerned with here. Not at all. Any other questions?
Yeah, this is out of scope for us, but just on that, is this also powerful enough to do impedance calculations too, when you have controlled impedance that you want to deal with?
Don't know that it is, because you have to know what type of material you're using, how thick it is, how thick the traces are, how wide the traces are, that kind of thing. And this link that Sam had for this
Yeah,
video.
I'll drop it in chat.
Yeah, go ahead and do that, Sam. I appreciate it. He talks about all those considerations and stuff. And so you really got to know what kind of material your vendor is going to make the boards out of. And that's kind of up to the design engineer to calculate that kind of thing.
There it is.
Thank you, Sam.
Mhm.
You know, maybe some of the other drawing programs might do that, like Eagle or no, I don't think this one does that at all. It does some other things. Let's see, just for grins. Here's a 3D preview. Let's see if all these parts have 3D. The diodes don't have a 3D image, but that's okay. Go ahead and pop this up here. And it'll do a 3D image of the board, and you can rotate it around and look at it. So that's kind of cool. If you want to see what your board is going to look like, and that might have come in handy on one of the projects I was working with, where I was had a vertical clearance problem. All right, adding component values and part numbers to the schematic. I sent you all a bill of materials with just a suggested list of part numbers, and top part is cap 100. These were all Mauser part numbers, so they're available locally, but you can use any parts you really want. And you can sit here and cut and paste those part numbers into the manufacturer field if you want. That's where I stuck them. And let's do this one too. I'll tell you what, it'd be better to do that on the schematic. And I already did that on this schematic. And here's a table that it generated. So let me delete that table. And if we look at the parts, here's the 555 timer. I put the part number in for that. It's a 595-NE555P. Again, it's a Mauser part number. Diodes, I didn't get that one. Let me look it up real quick. It's showing the manufacturer name there, but we can use that field for our part numbers. Okay. And then let's see, objects. If we go to objects and bill of materials, you can say place a table. That's not what I wanted. Control Z, object, bill of materials. And you can look, here's what it'll put in that bill of materials, the name, the manufacturer, quantity. And you can export that to a file if you want to make a CSV file, or you can place a table. And there's our bill of materials. One thing I didn't like, it was listed all the parts separately. But you can go here, right click, and say delete that row. Got the whole thing. Control Z. My friend, Control Z. Hit the wrong delete. That's what I did. Delete row. And just change this quantity to 2. And so you can tweak up the bill of materials. And delete that row. So you get the idea, right? The connectors are just a pad on the board, so you can delete those altogether. And got one resistor, 555. That's the pot potentiometer. And another connector male. We can delete him. And we don't need the total quantity of parts either.
Did you show where to put the chip socket?
Not yet.
Okay.
We can do that. Thank you, Sam.
And what was the link you used to pop that up again?
Which link is that?
Like, so you're looking at this. What was the option to pull this up?
Oh, to pull the bill of materials up?
Yes.
I think it's under objects. And bill of materials. Click that. And it gives you this window. Now you can also export this to a file. Say you want to bring it up in Excel, or you might want to create an Excel spreadsheet and import that into your vendor. I think Mauser has an option to do that. And I'll just say test, and it's going to stick it on my desktop. Save, and then make sure your column divider is a comma right there on that little window there. And it'll create a CSV file, comma separated variable file that you can work with in another program.
So column divider, change it to comma.
Make sure it's a comma, yeah. It wasn't in mine. I think I put a semicolon
Yeah,
or something weird like
mine
that.
defaulted to semicolon. All right, cool.
So it gives you a nice list of parts that you can work with and stuff. So I'm going to save this schematic. If we go back to our drawing here and say file, and let's update this, renew this by components, and we'll double click the schematic file name, and it will change those to the designated parts. Now if we look at that, the diodes got changed in that by part number, I believe. 3D preview. Yeah, so you see the diode name comes from a, they've got the model for that in there. But they're kind of buried halfway down the board. Don't ask me why, because I don't know. It's just a quirk that happened right there. But I'll show you how to fix it. So there, the leads are sticking way out the bottom and the diodes are halfway through the board. We know that's not right. But if you take and right click on one of the diodes and go down to 3D model and look up here, the Z axis is at a negative value. If you change that back to 0, everything will be right with the world. Go to 3D model, change that Z axis back to 0. And let me save that, and let's model that again. Tools, 3D modeling. And now the diodes are on top of the board where they belong. That was just a little quirk I ran across playing with 3D stuff. And I hadn't really done anything with 3D other than look at it one time before this class. So I had to go. These are things that I've picked up. I'm learning as much as you guys are in this class. The more you play with it, the more you learn. Everybody okay on part numbers and stuff? The other thing on the schematic, we've already got values there. Do you have values on your schematics?
No, I don't do that.
Okay. Under view and part markings, you can check the box that says show value, and it'll do them all for you. It should show all your part values. And again, you can hit F10 and move those around to make your schematic pretty. We got to have things pretty, right, Beth?
I did the visualization. I didn't see all those components. It just had a couple components. I just saw the board and then like the potentiometer and I think the 555 timer. The other components weren't showing up.
On 3D visualization?
Yeah.
You may have used something that doesn't have a 3D, a part that doesn't have a 3D pattern to it. If you want to hang around after class, we can take a look at that.
All right. Sounds good.
Let's see if we can't resolve that.
Hey, Steve, once again, tell me on the parts on the bill of material, how you remove the row?
Just right click on the row and say delete row. If you right click here, there's a delete row in that menu.
Thank you very much.
And you can add other things to it. Like say we wanted our, we want to place a bill of materials here and we want to add the values. As reference, where's value? Oh, that didn't work, did it? How about that? There's value. Okay. And we place a table. Now the table's got reference descriptions and values. So it's whatever you want to put in that table. We don't need connector mail. All right. I'm just going to get rid of this hole. One thing I did was I deleted the ports for VCC. You may not have been on the, and I actually deleted all the ground symbols and just connected them to a net named ground. Just to kind of simplify the drawing a little more, the schematic. The simpler, the better. Let's save that. Okay. Are we good on component values and part numbers? You just click on a part and you can fill in those fields. Like the value for that one, 1N4001. If we got the resistor, his value is a 1K resistor. And the manufacturer part number. You can fill those in, whatever your preference for part is. I've given you, emailed you a sample. Let's see, we covered setting the schematic to view the component values, right? That was in view, part markings. So if we uncheck the value, they're going to go away. And maybe you want that. Maybe you don't want it cluttered up with those initially. We'll put them back in here. Save that. Okay, on the printed circuit board, we want to put some text on there. And at the top, I'm back on the PCB board, click on the ABC thing here and just click your insertion point there. And I'm just going to put my call sign on there. Now, this is putting it on the top assembly. It will not show up on the silk screen, but I prefer to have it on the silk screen. So I'm going to, in the upper right corner of my screen, you can see where I pull down the menu there, the type. I'm going to change it to silk screen. And you see the color change. And hit escape here. And we can move that around just like any other text. If we prefer, you can put it up there.
I'm sorry, Steve, one more time. Could you show where you put that on there, put that call sign on there? Where was that again?
There's a little ABC at the top center of your screen. It says place text. If you mouse over it,
Yep.
Click that and then click an insertion point somewhere on the board there where you want it. And you can even click it if you want to. You can click it off to the side and create your text there. Like that, and move it afterwards.
And then you went to, what were the properties you changed it to again? Top silk?
Yes, if you want it to show up in the silk screen.
Got it.
And you can look at the font type and the font itself. And that's a 10 for that lower one here. I'll change that down to about a 6. Let's make that a little smaller. And put that in there. We already talked about pad sizes. We did that. And we want to check a clearance for that chip because we want to put a socket in there, right? And this capacitor over here might be just a little bit too close for comfort. And I looked up a particular manufacturer of dip sockets. And we scroll down here, and number of pins would be 8 pins, right? And so dimension A and C are 0.4 each. Let's see if I can find it. Okay, it's right here. Let's blow that up a little bit. So A is the length of the socket and C is the width. And they're both 0.4 inches. And so what I did just to make things really simple and easy, I drew a box around it in the silk screen. And let's see, placement, objects. And we go to objects and down to, let me find it. Place a shape. I'm just going to go down to a rectangle. I'm going to draw a rectangle here. And it's already in top silk, but it may not be on yours. You can see the dimensions there as I stretch that and draw that object. I'll make that 0.4 by 0.4. There we go. I hit escape. And well, actually, I want that line a little bit bigger too. Let's see if we can change properties of that. Custom width, 0.013. Let's make that 3. A little thicker line there. Oh, that wasn't it. That says line width. What the heck? Maybe it did change it. I just didn't see it. There we go. Got to go big or go home, huh? And let's just drag that guy and drop it around that chip. Just kind of place it evenly around the chip. I'll show you the outline of where the chip socket would go. So we got a box that's 0.4 by 0.4. And that cap is a little bit closer. I'll move that a little further away. Hit escape there. Let's move this guy over a little bit. That looks better. Okay, so now we know where our chip socket's going to land. And we got pretty good clearance. These aren't quite even. Anybody see anything else? That one's a little close. All right. Grid size. Sometimes you want to move a part to a particular spot and it doesn't want to go there. It doesn't want to stay where you want to put it. And what happens is the grid is too large. And here's snap to grid is turned on right now. So it will, if you see all the little dots, it's going to try to lock a part to those positions. And let's see, what does grid give us? That's not what I want. I want the grid size, and it's a custom one right now, but we could do a 1/10 of an inch, or we could do, I usually do one of these lower ones, 0.0125 or the very lowest one. And if you change that, it'll let you move things, do a fine adjustment of things. And then if we blow it up now, you see the grid is much smaller. the little dots for the grid. They're barely visible, but they're a lot closer together. And what Snap to Grid does is it'll lock things on a particular position and evenly space your parts for you. Kind of helps with all that instead of, and if there's a particular part that, you know, it just isn't lining up where you want it to, and there will be that occasional part that has an odd pin spacing on it and stuff, you can turn the Snap to Grid off. Just turn that guy off right there, and you can move that part. You move that part any amount you want to, and do a custom placement of it. But for most things, I would keep Snap to Grid turned on. It'll keep your drawing looking a little nicer. Any questions on that? There was a question that came up about had I ever created a home etched board from this program. No, I haven't, but I looked into how you would do that. And let's see, that's top. Is there any traces on the bottom? No, there are no traces on the bottom of this particular PC board. So if I wanted to create a PC board out of that, let's see, we could actually print that to some transfer paper. And here's the print preview. Go up to File and Print Preview. And here's my board. And we blow this guy up. What you don't want is you don't want all these part identifiers on there. And so you click on Objects. We want the pads. We want any vias. We want holes. Pin terminals. Traces. Any copper pores. We don't want any rat lines. We don't want solder mask. Paste. We don't want any of the silk screen. We don't want the assembly drawings. We don't want the courtyard. We don't want component outlines. All we want is stuff that's going to go on the copper board. And these are traces. We drew this with the traces on the top. You could get rid of the board outline. I like to have it so that I get a thin copper trace around my board and it shows me where to cut it and that kind of thing. Tables you don't want, dimensions you don't want. And so they're the things that you probably want to print out. But what you can do is mirror this guy, and now it becomes the bottom of your board. You put all the traces on the bottom. Haven't actually tried this, so. But if I unmirror it, here's negative. That might be one you use for photographic method. You actually print out a negative on some copy. What's that stuff called?
Transfer.
That transparent. Yeah.
Yeah, the resist.
Yeah, if you have a board that has photoresist, that's kind of an expensive process anymore. But you could do that. You could create a negative. And there's really nothing stopping you from putting your traces on top of the board either. And I did check print in black only. Otherwise you can get stuff in color like that. And it'll come out lighter on the laser printer. So if you check print in black, that will darken up those traces for you. But you take that transfer paper, you iron that onto your copper board, and then you soak it in water, and the paper comes away, and it leaves the toner behind as a resist. But I can't say I've tried that with this particular program yet. I may get brave. I may be impatient sometime and want a board right now, and dig out the etching solution and all that good stuff. One other thing on Print Preview, you can move this around on the board. If you click this little tool up here, you can put that anywhere on that sheet of paper that you want. So that's convenient if you're using like those transfer sheets. I would cut those in half and send them through the laser printer a half a sheet at a time instead of wasting a whole sheet on a little tiny board like this. And that seemed to work quite well. It just, you had to make sure you printed off your pattern in the right place. Anybody got any questions at this point? Next thing, copper pores. What are objects? And we're going to place a copper pore on this board. Right there. And you don't have to be real accurate because you can move it afterwards. I'm going to click once. And click again. Click a third time and hit return on the last one. And then you can have a pattern or just a solid. I typically do solid copper pour. And you hit OK. And it's going to put that on your board. Now, if you go all the way up to the edge here, let's see. Oop, moved everything there. I need the 4-way arrow here. There it is. I'll drag this into the middle of the board there. You got to have a little bit of clearance on the edge, according to one of the design rules. But I've seen some stuff go through OSH Park that I think they ran the pour all the way to the edge of the board. So I'm not 100% sure that you can't get away with that.
Won't that plate, when you go through the plating solution, won't that plate the through holes? Won't it plate the front pour to the back pour?
It will. Yep. When you, let me check. No errors there. You can check net connectivity too. That's a good thing to check. Make sure everything's connected. No errors there. And compare it to the schematic. Double click. No errors found. It's happy about everything at this point. You probably actually get it a little closer to the edge of the board down here. I've actually got to click on the edge of it to get the double arrows to move it. So the one thing you can do, let's see, where's the grounds? Here's the grounds. We can unroute those traces. And I think that's all our grounds right there. Okay, so we have those unrouted, and we can go to this copper pour here and look at his properties again. And over here on the middle tab, you can say connectivity. And right now it's not connected to anything, but we can connect that to ground. And hit OK. And let's update the copper pours now. That's interesting. It didn't put anything on the outside. What did I do wrong? Must be a design rule that's set wrong for this. Did you guys try yours? Let me check my design rules here. Zero 06. I'm gonna cheat here.
Yeah, and when you're done, could you review how you connected the copper pour to the ground? What was that again?
Go look at the, click on the edge of the pour itself and look at the properties. And the middle tab under the properties will give you connectivity. So it could be ground, it could be power. And these fields down here were 15 thousandths, right? 1.5. Okay. Or was it the board ones? Anybody remember where we got those design rules from?
That was from the that link you sent, the Osh Park.
Osh Park, yeah.
It was all 0.06 except for the very bottom one, which was 0.015.
The board, was it the board ones that were
Yeah,
15?
Board is 0.015. Everything else was 0.006.
Okay. Couldn't remember off the top of my head. Thank you, Sam.
Sure.
Just change these real quick here. See if that copper pour doesn't behave itself. If not, I may have a new problem to solve. Okay, so let's update all the copper pours again. Nope. Well, I'm not sure why it's not pouring copper out there. Let me get rid of those. I don't know. That's the first time I've run into that. Well, I'll have to play with that and see if I can figure out why this guy is not happy. It probably has to do with a clearance, but probably some setting that's not happy with it. Well, I guess I got some homework to do. Is this a good place to stop?
That's great, Steve. Thank you very much.
Let me show you one more thing. We'll give you.
Hey, Steve, got a question on the copper pour. I hadn't tried it on mine yet. If
Okay.
you've got one of those crosshatch top copper pour and you
Mhm.
connect it to like the ground, will it put a pad in there and it's on both sides of the board? To connect to the copper, or we'll just connect to a piece of the of that crosshatch net.
No, I believe you see a pad. You can do what's called a static via, and we'll show that later. Here's an instance, and here's a board that I shrunk down to 1 inch by 1 1/4 inches. That's pretty small. That's about as small as you're going to get it. And the copper pour worked fine. I'm not sure why that other one is balking at me right now. But there is one rat line that shows up here. This guy to here. There's no ground connection. If we did a verification on this one, check net connectivity, it's going to say, hey, ground is broken in 2 areas. And then you click on it and it'll highlight where the problem is. And you can see the rat line, the blue rat line right there that runs between there. So it needs a connection between there. The pads are too big to route between. So we've got to get a connection from there to there. And we can do that with with like a wire jumper if you want to, just to connect those. There was another board that I ended up with a copper pour in the middle just to fill in an area that didn't want to pour. And so I placed a second copper pour there and connected it with one of these. And so you could go to objects and place a static via right there. And if we had copper on the bottom side, we could do that as well. I put 2 static vias there. If we update the copper pour, we get a blank around there. And I hit escape, and I want to connect these to, I want to add these to the ground net. Select it from a list and ground. And same with this one. Add the net, select from a list, and hook it to ground. So now those 2 pads are hooked to ground, and if we update that copper pour, it fills that in. So now we just need a jumper wire, and we go up here like we're going to route a manual trace, except we're going to do something special here. We're going to, gives you some message there. You click once in the first hole, and then you right click, and you tell it, I want a jumper wire on the top. top jumper wire, and then hook the 2 holes together. And so we've got a jumper wire now. And notice the rat line disappeared. And if we do the verification again, check net connectivity, everything's happy. So that's how you'd add a jumper wire to your board. If you're trying to do a single-sided board and there's some area that just you can't get there, can't get it connected, there's actually a layout of this that you can get there. You can get everything with no jumpers, but this is a good time to show that. Let's call that a night. I'm starting to get hoarse here, and we've got a few more line items to finish off next week here. Got lots of good things to try. And we'll export the Gerbers and drop them on OSH Park. We haven't done that yet, right?
No.
Or did I do it? No, okay. We'll do that too. We'll show you what the board's going to look like. That's always fun. Anybody else got any questions or need help with anything? Sam, we were going to work on something for you, weren't we?
Yeah, although it wasn't really, I'm not really worried about it. It's not real. I know that was kind of a nice to have thing. So I'm not going to sweat it.
Okay, it was the 3D stuff.
It was the 3D. Like when I pull it up, I only saw the potentiometer, and I think it was the socket, or maybe it was the 555 component. I didn't see the other components, but that's fine. Well, we'll catch up on that some other time.
You should be able to see like the resistors and stuff, and maybe have to do with which resistor you picked. Did they show up on your 2D PC board?
So because I'm not actually running this on the same computer, but that's what I see. I don't know if you can see that, but
No, we can't see it.
Can't make it out.
I'm not going to work. That's
Do-
what I'm. That's
Do the
what I see.
resistors show up there though? Do they have a pattern,
Uh,
a 2D pattern?
yeah, there's just a box. It's just a box there. It looks
With
like
the
yours.
with the 2 pads?
You
Okay,
have like R2. Mine looks like R2.
right.
Just a
Right,
little
you
box.
got 2 pads.
Yeah, there's a pad for it.
Let me see what part I used. I used RES 400 for my part.
Let's see. I have the same RES 400.
And if you right click and you go down to 3D model on the part itself, you should be able to display the 3D model of that particular component.
Oh, I see. Yeah. Well, mine doesn't look the same. Mine looks like this.
That's interesting. Oh, I know, Sam. Go out to the download section where you got the software from, and there should be a link there for the 3D models, and download and install them. So if you're running on a older, slower, smaller computer and it's struggling with just the 2-dimensional stuff, you probably don't want to load the 3D libraries on top of that. It's about 1.5 gigs.
It's not
It's pretty. It's a pretty big library. Load that 3D library and try that again. See if that doesn't fix it.
Okay. I'll try that after.
Yeah, that's a separate install. Sorry about that.
This laptop here should be able to handle it.
Okay, that'll give you some 3D printouts for that stuff.
All right.
There is a and again the diodes were they're in the dirt in the middle of the board there. We want to zero those out. The Z axis. Bring that to the top of the board. I suppose you could bury a component into the board part way if you really had a wish to do that. Cut a hole in the board. Where was I going with this? 3D model and zero out the Z axis. Well, see if you can get your 3D previews working. Don't worry about the AWG16. It's just a pad. So you don't really need a 3D model for that one. But you could actually edit that and put your own 3D model in there, from some other model or whatever, if you know it's correct for what you're doing. And you can customize the 3D models if you want to. I haven't played with that a lot. I did do it a little with one component, but so there it all is. Even the jumper wires in there. So yeah, work on that this week. Shrink your board down. See if you can get it to. This one's down to 1.25 by 1 inch. And so that's area is 1.25 square inches. So at $5 a square inch, 5 times 1.25, $6.25 for 3 boards from OSH Park. So that starts to become affordable to just order some boards from them and do your little project. We've got mounting holes and everything in it. Pretty decent clearance on most everything. We might move these pads up a little bit, make a little more clearance for that trace. But I think if you printed this off and laid your parts on there, that's important too. One thing I did do, okay, let me point that out in this drawing. I went to a larger capacitor. I went to a C2 cap 200. And the reason being is it gives you enough room to route a trace underneath those caps. So that's something to consider, you know. Sometimes smaller isn't the best particular option. And maybe the caps you have in your junk box are a 0.2 inch distance between the leads. That's where that calipers comes in handy. Practice this week. The more you practice with it, the easier it becomes.
All right. Thanks, Steve. Appreciate it.
All righty.
See you
Thanks again, Steve.
Hey, no
all next
problem.
week.
We'll have some more fun next week.
I'm going to go ahead and take off. We'll see y'all next week.
Okay,
All
Sam.
right. Have a good one, Sam.
Yeah,
Thank
yeah.
you.
See if you can't get the 3D stuff working this week.
I'll give
Yeah.
it a shot.
I found my problem with 3D. It's not installed.
Yeah. That's a separate load, and it's fairly large. So,
Yeah. This is a fairly empty computer, so I'm good.
all
Now,
right.
the other one showed up and said no disk space. Now that one's got me concerned.
Oh no. Oh no.
Have a good one, guys. Good night.